Life is abundant on Earth. We frequently encounter it in the soil, water, and air. However, we have yet to find concrete evidence of life elsewhere in the universe. Nevertheless, scientists continue their research, and these studies tell us that we should look for three fundamental components that make life possible. These are liquid water, chemistry, and energy. Additionally, as far as we know, the emergence and evolution of life take a considerable amount of time. So if we are looking for life in space, we should search for it in a place at least as old as Earth. Jupiter's icy moon, Europa, might possess these essential components and could be as old as Earth. In fact, it is one of the celestial bodies where hopes for extraterrestrial life are highest. This is because beneath the thick ice layers of this small moon lies a vast ocean. Research indicates that this ocean contains both carbon dioxide and organic molecules. If you want more detailed information about Europa, you can watch this video where I explain this small moon in detail. Because this video will be the 5th episode of the Speculative Evolution series, and in this video, we will make predictions about what life on Europa might look like. But before we do that, please don't forget to like the video and subscribe to the channel. Music. Nowadays, scientists believe that life on Europa could be unicellular or might have a slightly more complex form. This idea is quite logical. Whenever life was sought in the most inhospitable regions of the world, we often encountered microorganisms adapted to these extreme environments. Even at the bottom of the Mariana Trench, various species were found, including complex organisms. Moreover, bacteria that live through chemosynthesis were detected in this deepest point of our planet. These bacteria, living under deadly pressure without any light source, cling to the rocks at the seabed, and they can sustain their lives by performing chemosynthesis using the minerals in these rocks. Chemosynthesis is the process of producing organic matter from inorganic substances using energy other than light. Such lifestyles might exist on Europa, and the first place we might encounter this life on Europa could be right beneath this ice layer. For example, when you look at the thick ice layer of Europa, one of the most striking things you'll notice are these reddish and brownish lines. These lines indicate the cracks in Europa's ice layer. Observations suggest that these cracks are formed due to the tidal forces Jupiter exerts on Europa, and this tidal force keeps the ocean on Europa warm. The reason for the redness of these cracks is thought to be the minerals and salts coming from the ocean below. However, some scientists suggest that the colors might be due to microorganisms suspended in Europa's ice. Moreover, a study conducted by planetary geologist Brad Dalton in 2003 pointed to such a possibility. Brad Dalton compared the infrared signatures of Europa's ice layer with the infrared signatures of extremophile bacteria and noticed they were very similar. He then subjected extremophile bacteria like Deinococcus radiodurans and Cephalobus shate, which live in geothermal regions, to conditions similar to Europa. The results showed that the infrared signatures of these bacteria resembled the infrared signatures in Europa's ice layers. Interestingly, the colors of these extremophile bacteria are pink and brown, just like the cracks on Europa. In short, extremophile organisms might also explain why these cracks on Europa's outer layer are colored. In summary, there might be colonies of microorganisms suspended beneath Europa's thick ice layer. Moreover, it's believed that these microorganism colonies might also exist in ponds formed within the ice layers, as studies have shown the presence of such ponds within the ice. For instance, a study in 2011 discovered a body of water about 3 km below Europa's surface, larger than the Great Lakes in North America. As you can see, even though our first stop is this thick ice layer, there's a possibility that it harbors life. But deeper within the moon, there are even more astonishing possibilities. Because once we pass through this ice layer and go deeper, we encounter a vast ocean, believed to be between 60 to 150 km deep. And in this ocean, there might be complex life forms. At this point, many people might think that this deep ocean on Europa would have a deadly pressure. However, this isn't entirely true, because the gravitational force on Europa is much weaker than Earth, and its gravity is about 13% of Earth's. Therefore, even though this ocean is very deep, its pressure is much less than on Earth. For example, the pressure at the Mariana Trench, the deepest point on Earth located 11 kilometers below the ocean's surface, is 1086 bar. The equivalent pressure on Europa would be at a depth of about 78 kilometers. So, even if this ocean on Europa is 60 kilometers deep, the pressure at this depth would be much less than the Mariana Trench. And life could exist here. Even if this ocean is 150 kilometers deep, life could still exist despite the pressure difference. Moreover, in the coming years, vehicles sent there could easily search for life in this ocean. Because today there are vehicles that can descend into the Mariana Trench, move around comfortably, and collect data. In fact, there are even tourist trips to the Mariana Trench now. As you can see, the oceans on Europa are not that different in terms of pressure from Earth's oceans. So, what kind of life forms might these oceans harbor? Music. Before trying to predict life in these oceans, it's worth noting that as humans, we tend to imagine extraterrestrial life forms based on life on Earth. Therefore, in the initial stages, we have to liken the possible life forms in Europa's oceans to those on Earth, as we have no other reference for life. However, in the coming years, underwater vehicles sent to this moon might encounter life forms beyond our imagination. But for now, to understand what they might look like, we should look at the deepest points on Earth and the surroundings of geothermal vents in the deep sea. Firstly, if we look around the Mariana Trench, we would see creatures known as snailfish. Snailfish have undergone many evolutionary changes to be able to live in the Mariana Trench. For instance, they have lost all their colors, almost becoming transparent, and have enlarged organs like their stomach to survive. They have even evolved down to their cell membranes to withstand the deadly pressure. Studies have shown that some of the bones of snailfish are missing, but their skull is made of bone. Additionally, it's believed that these creatures have very little or no vision. The reason for these seemingly lacking features is entirely related to energy efficiency. Because extra bones, functional eyes, or colorful scales mean more energy consumption, and in the nutrient scarcity of the Mariana Trench, energy means everything. Moreover, such features have no function at such depths. For example, even if these fish had functional eyes, they wouldn't find any light to use them in this dark environment, as there are very few light-emitting creatures in the Mariana Trench. Therefore, these creatures look very different from their relatives living in other parts of the ocean. Similarly, possible life forms on Europa might look transparent like snailfish or creatures living in the Mariana Trench, but some of their features will be very different. This is because the creatures in the Mariana Trench have ancestors that have seen light or developed eyes. But the possible creatures on Europa would come from ancestors that existed in darkness. Therefore, it doesn't seem likely that they would develop organs like these, as they would never need them. However, they might develop organs that can detect sound or heat, and there might be creatures that use these organs to hunt. Some of these creatures might grow to large sizes. So, what will these creatures feed on? And can an ecosystem exist here? If you recall, around the 3-minute mark of the video, I mentioned that there might be bacterial colonies attached to the underside of Europa's ice layer, and these bacteria could perform chemosynthesis, converting inorganic substances to organic ones. These organic substances would slowly fall due to gravity, and creatures that filter these substances from the water could feed on them. Since the organic matter falls slowly, these creatures would probably move very slowly as well. Moreover, they wouldn't need to live too deep, as the nutrients they need would come from above. Filtering nutrients from the water is one of the oldest forms of feeding, and this was first done by a creature known as Tamisiocaris borealis around 485 to 540 million years ago. Therefore, there might be various creatures of different sizes on Europa that feed in this manner. These transparent creatures, when they die, will fall to the ocean floor and be consumed by scavengers. But not only scavengers, there might also be other creatures that hunt or consume them. For example, creatures with an appearance similar to octopuses might attach themselves to these giant filter feeders and feed on them like parasites. Or if life here has evolved enough, there might be top predators that hunt in groups. All these creatures, when they die, will fall to the ocean floor and be consumed by creatures living there. These bottom-dwelling creatures might have a strange mix of both vertebrate and invertebrate features due to the high pressure, allowing them to withstand the pressure. Along with these, the majority of life here will be centered around hydrothermal vents that keep Europa's oceans warm. The existence of such hydrothermal vents on Earth was first discovered in the 1970s, and it was observed that the creatures around these vents lived on the dusty chemical deposits and nutrients found in the hydrothermal fluids. Many of these creatures were found to live through chemosynthesis. Similarly, such vents might exist on Europa. In fact, life here might have first formed around these vents, as estimates show that the only energy source here might be these possible hydrothermal vents. Therefore, those hypothetical bacteria attached to Europa's ice layer might have originally come from the ocean floor. Lastly, remember that the ecosystem we've constructed in this video is purely speculative and is just a part of a speculative evolution episode. However, in the future, exploration missions will surely be organized to this frozen moon, and when that happens, human-made exploration vehicles will roam the oceans of Europa. These vehicles will try to detect alien life forms, and when they do, this discovery will likely be called the second creation. However, when we get there, we might also find that these oceans are completely empty, dark, and desolate. At this point, the only question that will come to our minds will be Enrico Fermi's question: where is everybody?